Hey guys, here we go. Get back on it after yesterday's issue of no internet for 3 hours. It looks like the same hat, but actually it's not. It's got a fan on it. It's got a hole in the back, solar powered. It actually spins and then cools my head off when it's hot. The only problem is that sometimes if my hair is too long like it was, it gets caught and it gets caught in the fan and it hurts bad. But here we go. All right, guys. So today, 11.3 trigonometric functions of general angles. We're going to talk about using a coordinate pair, figure out how to find a reference angle, label the triangle, and then the reference angle in all quadrants. So let's just kind of take a piece here and let's just label the coordinate, man, I can't spell early in the morning, coordinate, and then let's call it -3 point P, -3 and -4. So if we just do our basic, which a lot of you know how to do, there may be a few that get a little confused. We know that this is X and this is Y. So I go over 3 left because this is my x-axis, this is my y-axis, and I go down 4. And I put my point right here, -3 and -4. So this allows us to do a couple of different things. Number one, if we want to draw a triangle, we know a few things about it. We know that this side is -3. We know that this side is -4. And we know that this side here is our radius, because it can be drawn in a circle, or it's our hypotenuse. Okay, because we just made a right triangle right here by drawing a perpendicular line. So just by drawing a point like that tells us multiple pieces. Now, pay attention to signs. So pay attention to quadrant, because if you don't pay attention to the quadrant, that's going to affect our sign. So if you notice, I labeled it here. Okay, so let's talk about, so we used the coordinate pair right here. So we've used the coordinate pair to draw our triangle. So look, I've labeled and I've drawn my triangle already. So now, where's my reference angle at? Well, right now, our reference angles are always from the x-axis. So this is my reference angle right there. That's always the reference angle. And that's always from the x-axis to the terminal side. So, bigger parentheses. So in other words, I start at the x-axis and I go to the terminal side, because this is actually the orange piece here. The orange piece is the terminal side. Okay? So this graph, or this standard angle, really goes all the way around to here, doesn't it? So it opens up like that. So with that type of information, we can find out some different pieces. First thing they want to know, let's say, is find all 6 trig functions. So if we want to find all 6 trig functions, we'll call this theta. Oh, by the way, theta prime, that's a reference angle, and I'll explain that, and then this whole thing is theta, is what they say. in this book. There's different ways to look at it, but that's the idea. So find all 6 trig functions. So if this is theta, this is opposite. Oops. This is adjacent. It's always that way. So our x-axis is always adjacent. And our y value is always opposite. Always. Doesn't matter what quadrant it's in, and we'll talk about that. So this side is always opposite, this side is always adjacent. All right. And the middle coming out is always the hypotenuse, r, or r. So I'm given a squared, b squared. I just need to find c squared. So r squared, we'll just stay with the same labels. R squared, which is the same as c squared, is equal to -3 plus -4 squared. R squared is equal to 25. R is equal to 25. So if we look at this, sine of theta is equal to opposite over hypotenuse. So it's opposite over hypotenuse, or in your book, it calls it y over r. Because remember, y is always the opposite, which is going to be -3 over 5. So my cosine of theta is adjacent over hypotenuse, which is x over r, which is -4. Oops, this one's -4. Messed up, -4. -3 over 5. And my tangent of theta is opposite over adjacent, which is y over x, which is -4 over -3, which is 4/3. And then to find my other 3, cosecant, we flip this over, cosine, we flip that over, and tangent, we flip that over. So using a point, we just draw the point in, we label the triangle, and we go from there. So let's go ahead and let's tackle another one real quick for you guys. You guys can do this on your own if you'd like. I'm going to go ahead and erase this. And I'm going to pick -6 and 2. So we're going to go with point P, -6 and 2. And I just want you to find sine, cosine, and tangent. So always draw in our graphing piece. We're going to draw our x-axis, our y-axis. We are going to go x value to the left, -6. We're going to go y value up to and we don't know what our r is. Okay? Our reference angle is always from the x-axis to the terminal side. Oops, that one's dead. X-axis to the terminal side. There we go. There's my reference angle. There's my entire theta, standard angle, and terminal side right here. So I've got all the pieces I have. So what are we given? We are given an opposite side of 2, an adjacent side of -6, and we do not know what our hypotenuse is. So we got to find it. How do we find it? R squared equals -6 squared plus 2 squared. We finish this up. We got 36 plus 4. R squared equals 40. R equals the square root of 40, which can be 2 square roots of 10. So how did I get there? I took the square root of 4 times the square root of 10, which is square root of 40. What's the square root of 4? It's 2, and 10 goes right there. Okay. So there's my radius. So then I want sine. Sine is going to equal opposite over hypotenuse, which is the same as y over r, which is the same as 2 over 2 root 10. Well, if we simplify this out, that becomes 1 over root 10, and this becomes 10 root 10 over 10. So remember, to get there, we multiply the top and bottom by root 10, and then back up. Okay? So I may have to go a little bit different. Adjacent over x over r, and that's going to be negative 6 over 2 root 10, which is going to be negative 3 root 10. 2 goes into 6, and we end up with negative 3 root 10 over root 10. So either one. Remember, this is the way the book answers will have it. That's the way we can do it. And then our last one, remember, this is in numerical. I didn't organize it very well today. Numerical. And then tangent is opposite over adjacent, which is equal to y over x, which is equal to 2 over negative 6, which is equal to negative 1/3. Okay, so that first part of the assignment tonight, all we're doing is stuff like this: find the sine, cosine, tangent, cosecant, secant, cotangent. We label our point, we label the triangle, we find the missing hypotenuse or radius based on the reference angle that's always off the x-axis. Then we do the Pythagorean theorem with our given, and then plug it into the equations there. Okay, so that's our big labeling the triangle piece. So here's our last thing. So, finding reference angles. So I'm going to draw a little bit larger we have our x, we have our y, okay, and we know we're quadrant 1, so that's quadrant 1, quadrant 2, quadrant 3, and then our last one is quadrant 4. All right, so let's look at this. So if we look at this in quadrant 1, from 0 to 90 degrees, so our theta is going to be between 0 and 90 degrees, or between 0 and pi over 2 if you converted this into radians. We know that my reference angle, which is theta prime, is equal to theta. So in other words, if it's 30 degrees for theta, my reference angle is 30 degrees. That's in quadrant 1. Quadrant 2, I used orange and I shouldn't have. Well, that just irritates me, so we're going to do this. Quadrant 1. There's my brown one. Quadrant 2. So let's look at this. So we're in a little different area now. We've opened up from here all the way to somewhere in quadrant 2. So based on this, quadrant 2 is going to be pretty much from 90 to 180 degrees. So our theta will be from 90 to 180 degrees, which is going to be pi over 2 to pi. Okay, so it's got to be between 90 and 180 degrees. This is my theta here's my reference angle. Remember, the reference angle is always from the x-axis to the terminal side. So this is my reference angle. So how would we calculate this? The reference angle is 180 degrees minus your standard angle. Okay? So if this was 120 degrees, it's 180 minus 120. Let's go to quadrant 3 real quick. And again, this is getting a little big. I may have to clean it up. We can go all the way around. You can draw these in different quadrants. So we're going all the way around. Where is it at? It's between 180 and 270. 180 theta 270, which is pi to 3 pi over 2 radians. All right, so now we're all the way here. Here's my theta reference angle. Oops. Here's my reference angle. How do I calculate the reference angle? Well, it's bigger than 180, so my reference angle is equal to the standard angle, theta, minus 180 degrees. Notice these two flipped because this time the standard angle is less than 180, this time it's greater than 180. All right, so here's our last piece. This one's in red. So this is the one that goes all the way around to a terminal side here. It's getting a little gummed up, but you guys hang in there. 270 back to 360, 270 degrees, which is 3 pi over 2 in radians. It's not x, it's theta, and that is 2 pi. So, where this is the one that kind of messes with everybody's brain. We're almost to 360, but we got to be past 270. So the question I have for you is the standard angle greater or less than 360? Well, it's less than 360, so the easiest way to find our reference angle is take the larger number and subtract the smaller number, which is our standard angle that goes all the way around. Okay? So let's tackle a couple of these. It'll make you kind of look at it a little differently here. So let's erase the stuff inside here, and we'll do a couple of examples, and we'll be done for today. All right. Okay. All right. Okay. So here we go. That's 270, and this is 0 and 360. Let's find the reference angle. For 210 degrees. So 210. Start here. And go all the way around. It's past 180 and in between 270. So we'll stop it right here. So my question is, what's the reference angle? This formula, the reference angle is the 180. Oops, sorry, not the 180. It's the standard angle, which is 210 minus 180 degrees, which theta is equal to, the reference angle is equal to 30 degrees. So that's 30 degrees. So we're just using that formula that I showed you guys prior to this. All right, so let's go ahead and tackle another one real quick. All right, let's do reference angle for, that's angle sign, for 11 pi over 6. Oh, what do I do? It's in radians. Easiest thing to do, convert it to degrees. So we're going to do 180 over pi. This is where all those little conversions come in. Pi's cancel. 6 goes into 180. 30 times 11 is 330 degrees. So 330 degrees is bigger than 270, but less than 360. I'm going to go like this. Almost here. Draw my point. Theta is equal to 330 degrees. What's my reference angle? It's going to be the larger number, 360 degrees. Reference angle is equal to 360 degrees minus the smaller number. Whoops, 330, which is equal to 30 degrees again. Okay, so my reference angle is 30 degrees. So that's kind of how we tackle dealing with standard angle. And that should get you through today's work. And we will talk to you guys soon with a different hat on.